rational expressions with negative exponents, or complex fractions with negative exponents. This is definitely a little bit of an extension. I think it's great. I think it's really important. Anytime we can get exponent rules going on with what we're doing, I think it's a great way to prepare for AP Calculus. If you are not comfortable with complex fractions yet, work on complex fractions first and then come back to this lesson. If you are good with complex fractions, you're doing great with that, and this is a great thing for you to be working on. So when you see these negative exponents, the first thing you have to do is make fractions. If you don't make the fractions, you're kind of sunk. So what I'm going to do is go through and highlight everything or circle everything in a different color here that we need to make drop to a denominator. So we need to drop a to the negative 1 and 2 to the negative 1 and b to the negative 1. These are all going to become their own fractions. The rest of the situation is going to stay the same. So the 30 is going to stay there. That's 3 over 1. And you guys know at this point, if we have fractions everywhere, I'm going to lean into it. We're going to do fractions everywhere. So that was 3 times a to the negative 1. So that a, I'm going to drop into the denominator. That's going to become 1 over a to the first. Minus 2 to the negative 1 is the same as 1/2. On the bottom, I'm going to go ahead and make that 1 over 1 minus, and our last fraction to create here is with a b. So that's going to be 1 over b to the first. And now you basically just made this into a complex fractions problem. The other thing I'm going to do here before I start making common denominators, this is one fraction here. So this is really 3 times 1 over 1 times a. And now we can make common denominators on top and bottom and simplify. So my numerator has an a and a 2 in the denominators. So I need to multiply my first fraction by that 2 over 2, and my second fraction by a over a. So the numerator here, 2 times 3 times 1 is 6, over 2 times 1 times a is 2a, minus 1 times a is just a, and in the bottom, 2 times a is 2a. So my numerator is 6 minus a over 2a. And now I'm going to work with the denominator. And you can do, whatever order you want, just like when we were working with our other complex fractions. I kind of like getting the numerator as simple as possible, getting the denominator as simple as possible, and then combining them. Okay, so I have 1 over 1 and 1 over b, so I just need to change this 1 over 1 into b over b. So I have b times 1 is b, minus 1 over b, which is b minus 1 over b. From here, you're just going to work the complex fraction. I like leaving it stacked and doing this business that you've seen me do in class. If you flip the second and multiply, what you're flipping is that bottom fraction. But no matter which process you like, you will get this. So the top is going to be b times 6 minus a, and the bottom is going to be 2a times b minus 1. There's not going to be anything else that we can simplify, but if you would like to multiply those through, 6b minus ab over, you can always leave that denominator factor. I like the denominator factor, but for this one, that works beautifully. All right, let's look at this. Number 2 is also a mess of a's and b's. Again, I think it's a really good practice to kind of circle what you're going to convert into fractions, or really, with these, you're just dropping them to the denominators so that you don't over fraction things. All right, so My a to the negative 1 is going to turn into 1 over a. My b to the negative 2 is going to turn into 1 over b squared. A, b to the negative 2, that a is going to stay on top and the b squared is going to go to the bottom. If you want to break it up, I think it is helpful to kind of look at it like that. Kind of look at those separately before you make them into one fraction. So here, b on top, a cubed on the bottom. And now that we have our complex fraction going, we can just common denominator and kind of fly here. So I'm just going to work the top until I have it fully simplified. My first fraction, 1 over a, needs b squared over b squared. 1 over b squared needs a over a. So my common denominator is a b squared. And in my numerator, b squared times 1 is b squared. 1 times a is a. Fight the urge to cancel anything there. If you can't factor, you can't cancel. And there's nothing that you can factor out there. Or we can't cancel over addition. Because canceling is division. Division and addition cannot go together. All right, denominator. My b squared fraction needs a cubed times a cubed over a cubed. And my a cubed fraction needs b squared, b squared. Lots of a's and b's here. My denominator looks like this. A cubed b squared. My numerator is a cubed times a, so a to the 4th plus b times b squared, b cubed. Lovely. And now we group, or however you like to do this business. Flip the second. Again, if you flip the second, you're flipping the bottom. You like to group these. The outsides are the top, the insides are the bottom. So my numerator looks like this. A cubed b squared times b squared plus a. And my denominator, a b squared times b to the 4th plus b cubed. At this point, we can cancel a little. We have multiplication out front here. So we can cancel with our multiplication. So I'm going to look at this. A cubed over a, that cancels the a squared on top. B squareds cancel. And that is as simple as that guy is going to be. So you can multiply and add a squared if you would like. So you would get a squared b squared plus a cubed over a to the 4th plus b to the 4th. Or you can leave it factored out. They're equivalent. All right, one more example. It's actually the quickest one of the 3 examples. We have p plus p to the negative 1 cubed to the negative 2. So, again, I like going all in on fractions. And this one is not going to be a complex fraction. It's just a fraction problem. P to the 1st is going to drop to the denominator. Q squared is going to drop to the denominator. And since nothing is up top, we need a 1. And so for this one, all we need to do is multiply my denominator is q squared. My numerator is p squared, q squared, plus 1. Just really want to reinforce that you need to use those negative exponents carefully. You have to do that first step right in order to keep rolling with a complex or any fraction here. All right, there's practice that follows this. There's 6 problems. Here are the answers so that you can check your work once you get it done. Awesome, let me know if I can help.